Hi everyone, my name is Segun Adebayo. I'm the creator and maintainer of Chakra UI, and I'm really excited to be here today. In this talk, I'm going to show you how to build UI components with state machines. The key outline for today's talk, I'm going to walk you through how to create state machines, why state machines in the first place. I'm going to show you the fundamentals of state machines, how to visualize state machines, how to use state machines in your favorite framework like React or Vue or Solid or Svelte, and how to manage logic changes within your application or component. The core tenet of any application these days typically involves two key aspects: user interaction design, which is how it looks, and software construction, which is basically how it works from the state management to data fetching and mutation and so on. If you've been in this industry for quite some time, you notice that actually developing user interfaces that are easy to test, easy to enhance, and easy to debug is quite difficult. And the reason why this happens typically is because we start off when building a software, we start off typically with a 1 to 2 week sprint, just trying to get our features in and let's just make it work. And typically we go week by week, sprint by sprint, just making the thing work and not paying enough attention to the overarching software design or the logic behind what we're building. And typically when anyone joins your team and asks you, how does this software work or how does this feature work? You tell them, hey, go check the code. I'm not sure I really fully understand. And that's usually because we've built quite a lot of inherent complexities in the code itself. To help illustrate this problem or to help illustrate this challenge, we're going to be building a stopwatch component. And just as you see in the pictures here, the stopwatch basically is a timer that counts upwards and allows you to create multiple laps within the interface. You can stop it, you can reset it, you can restart the stopwatch as needed. To build this with classic React, you usually need to create some sort of use interval hook that helps you create these ticking effects in a memory efficient way. And this usually involves importing or bringing in a couple of React hooks, such as useRef, useEffect, to sort of clean up the logic and save the callback. And on the right hand side, you have to create a bunch of use states, which is to keep track of the laps, total laps you've sort of clicked on so far, and to also keep track of the current second value and to know whether the machine or the component is ticking or not. And after you do that, you need to do a couple of memorization techniques to make sure you don't run functions or recreate functions unnecessary like use callback. I've hidden most of the code and implementation detail just to show you, like, just with this little snippet, there's quite a lot of inherent complexities already. You've seen a couple of use refs, a couple of use effects, a couple of use states, and a couple of use callbacks. These are usually framework-specific idioms, and usually what happens for someone who is very new to React or very new to frameworks, they tend to struggle. If you tell them, hey, I need to update a component to include a new feature or fix a bug, there's usually some inherent challenge, and they go like, I'm not really sure what to fix or what to change because I don't want to introduce new problems to this software or to this feature just because of this new thing or fix I'm about to make. And the key root of this problem is what I call tight coupling. There's usually a tight coupling between the framework itself and the software or the feature logic. And this means that people tend to then become like framework specialists, which means you're usually like an expert in React or expert in Vue. But the key thing behind software design is not to really focus on the framework itself because your favorite framework will not be around for too long. And the key thing to do instead is to focus on how do we develop or model our software or features in a way that are not exactly tied to the framework itself. And you don't need full understanding of the framework to be able to understand the system or make improvements to that system. At the end of the day, we find that our code can, over time tend to be, at the end of the day, we find that our code can tend to either be very hard to read because of all the different framework idioms sort of connected to this software itself. Can sometimes be hard to test because if you don't understand the code, it's really hard to really model the test correctly. Sometimes you might introduce bugs due to unintended side effects, and each time you're requested to create a new feature or fix a bug, it just leads to a bit more frustration and you're unhappy because you're about to work with a code that you're not really so comfortable with because you don't understand. And these are the problems that state machines are here to help us solve. State machines or state charts, I can use these two words interchangeably. They were invented in 1987, yes, as far back as 1987, by Professor David Arrow, and they were originally designed or created to model complex logic in an aircraft's electronic system. You can imagine how difficult this could have been without using a state chart back then. But now these systems and these ideas are now used in telecommunication industry, electronic design, and even game design, and so on. But these days we find that it's slowly gaining steam in the web development space thanks to new tools that are showing up now. To help you really understand what state machines are, because I know you might be thinking, okay, what is this state machine thing itself? So let me just show you the core foundations of a state machine. It's a pattern in itself, and it includes 4 different areas. The first one is for you to model a logic as a state machine, it needs to have a finite number of states. For the stopwatch we want to build, let's assume it includes the idle state, which means you just open the stopwatch app, no interactions just yet. A ticking state, which means you click the start button and it starts to count upwards. And a pause state, which means let's say you hit the pause button and it just pauses there. The next thing you need to take care of is there must be a finite number of events or transitions. So basically, what this means is you can send a start event to the machine and it's going to respond to that. You can send a stop event to the machine, it's going to respond to that. Or you can send a pause event to the machine. So all of these events, you tend to create them ahead of time for every single state, depending on what you need or the requirements for your application. The next thing is there must be an initial state. So as we described earlier, there's the idle state, the ticking state, and the pause state. So we have to pick an initial state for the machine to start in. And let's just assume for the sake of this example, it's gonna be the idle state, which happens when you just launch the app itself. And then the last thing is a piece of extended state or data. So this is literally the data requirements for your components that you need. Maybe something you need to show in the UI that is actually exposed to the user interface itself. Now let's look at the model of a stopwatch when modeled correctly as a state chart in the different states. We see here that we have 3 different states: the idle state, the ticking state, and the pause state. In the idle state, basically when you just launch the stopwatch app itself, you see that it's all idle. You can click the start button to take it to the ticking state where it starts to count upwards. So we need to set up some sort of timer interval action there to keep incrementing the seconds. And when we're in this state, we can send in a lap event, which is to record the time that we spent so far. We can send in a pause state, which means we would like to pause this ticking state and just freeze everything at that point in time. And when we're in this pause state, we can reset, which means take me back to the idle state where it was when I initially launched the app, or start, which means resume the ticking process. Now, while we're in all these 3 states, it's really crucial for us to have some sort of data that we manipulate. And the 2 pieces of data that are very important are the total number of seconds so far and the laps. So which means as we keep clicking on the lap button, we just keep track of these laps in there. To illustrate this state chart with a diagram, we can visually see how this stopwatch works by looking at this flow chart here. We see that we have the idle state, the taking state, and the pause state, and we mark the idle state to be the initial using the asterisk. When we send the start event, it goes to the ticking state, and in this ticking state, there's a tick interval action that keeps happening there, as you can see with the tick event. And from the ticking state, you can send a pause event to the machine, and that will take it to the pause state. And when we're in the pause state, you can either reset to go back to the idle state, or send a start or resume event, which basically takes it back to the ticking and lets the timer action keep running. So this gives you a fair enough idea of how the component logic works. And while we are in there, there's a central circle you see in this diagram called the context, which is the data, and this holds the total number of seconds that's been elapsed so far, and the total number of laps as you keep pressing the lap button. Model state machines in JavaScript, we're going to use the library xstate. Xstate has been one of my best libraries so far as modeling complex logic goes, and I've used it a couple of times to build very complex components. On the right, you see a function called createMachine. CreateMachine is basically the function from xstate that allows you provide an argument which describes the logic of your component. And the key components of this object is, first of all, the ID, which is the unique identifier for that component you want to model. In this case, we're going to call it the stopwatch. The next thing is the context, or the piece of data you'd like to modify as you switch between states. This would typically include the seconds or the value, the current value of seconds there, and the second argument or the second property that goes in there is the laps. Now we already identify idle state to be our initial state, so I'm going to walk you through as we go each state, how do we define the transition between each state. But before we do that, we need to approach an interesting perspective here. So the fresh perspective that state charts bring to us is the fact that we need to model our components in a framework agnostic way, in a way that is not connected to a specific framework. It is just vanilla JavaScript, and it can be run on any environment. You can run it in Node.js on the back end, you can run it on the front end regardless of the framework, React or Vue, and if you need to integrate with any specific framework, we can also just, create bindings for this machine. And this is really where xstate shines. I'm going to show you how to set this up specifically for React for now. So back to xstate. In the idle state, we mentioned that you can send the start event. Within xstate, while you're defining the configuration of your logic, you see here that there's an on key. The on property here helps you define all the possible events that you can send to the machine while it's in this state. So while it's in the idle state here, you can send the start event. And when the start event is sent to the target equals ticking you see here means we are transitioning the machine to the ticking state, and you're executing a couple of actions, which means record lap, which just tells the machine to record a new lap, a fresh lap in there, and add the first lap into the context. When we're in the ticking state, we're using this invoke keyword, which is a way to set up the timer action. And based on the DOM, we have a set interval and a clear interval. So we use this ticking invoke property there to actually set this up within the machine itself. And when we are in here, we can execute two things. Based on the left, you can see the UI representation that we can send the lap event and the pause event. When we send the lap event, we're basically just recording a lap. We're not leaving the ticking state, which means the timer action still runs. We're only just recording the lap itself. When you send the pause event, here is where the state transition happens because we're going from the ticking state, changing the state to the pause state. And in this pause state, two key events that we can run is reset, which means take me back to the idle state, just like when I launched the app, and also clear all the possible values that has been logged before. So the timer was previously incrementing the seconds, but now just clear everything, clear the laps, and take me back to the idle state. That's exactly what we've described here on the right here. And if you also send the start event, you're telling the machine to take you back to the ticking state where the timer action starts to run, and it picks up from where it stopped before. So this is a quick overview of how you can interpret all the different state transitions I showed you earlier on the diagram into something that can be modeled in xstate and state machines. The next thing you think about is, okay, cool, I've been able to model this machine correctly. How do I use it within my framework? Because, hey, I'm using a framework for my company and we're building a software in React. So after modeling your logic using the createMachine function I showed earlier from xstate, you can then consume this within a framework. To use this within React, xstate exposes an xstate React package you can install. And this package gives you access to a hook called useMachine. And with this useMachine hook, you can consume the machine within React put the machine in there, and it exposes to you a state which gives you a current representation of the machine state. And a send, if you're used to reducer pattern or redux, this is very synonymous to the dispatch function. Right now I just chose to call it send, where so we have the state and the send, which are basically the output from this use machine hook. And then the next thing we do after that is we tend to, one of the best practices for me when I create machines, I tend to create an API surface for the machine, which means I take all the things that comes from the machine and I provide a very useful object. I return an object that represents all the things I need for my UI. To help you make sense of all these different ideas that I just shared, let's take a live demo. We are in the live demo. On the right here, you can see the Vite app set up and running already, and we have the UI. And here you have the display of the current seconds formatted, and then you have all the different functions that we need for the stopwatch. We have lap, reset, start, and pause. And down here, I'm giving you a visual representation of the state of the machine, so you can see how everything changes as we go between states. So right here on the left, you see the code itself. Just as I explained earlier, we're using the use machine from XState. We're creating an API surface here. And all the API surface does on the left, I'll give you some more detail. All it does at the end of the day is sort of to return properties that you can use in your UI, such as show lap, show reset, show start button, show the pause button, and different callbacks such as start, pause, reset, and lap. Right, and all that they do at the end of the day is just to send events to the machine using the send function. So that is exactly what is going on within this API right here. And the third thing we do then is just to render our UI. Again, note that we don't have any React specific idioms, use state, use effect in here. It's basically creating the machine logic and using the machine logic. And then we have a pure JavaScript function that just helps us really make it a little bit easy to use the machine logic in our UI, right? So there you see that here in the button that says lap, we're just sending the lap event, which basically, we're invoking the lap function, which basically sends the lap event to the machine. So this is what I mean by creating that API surface. So you just return only the things you need for the UI. And here we have the reset, and it goes on and on to sort of show you how we show or how we present the machine state in the UI there. So this way your machine or your UI is not tied to the logic. As basically logic lives in isolation in a pure JavaScript environment. You're using the logic in React and then you're rendering your UI. So let's see how this works again. So I'm going to refresh the Vite app and I'm going to click the start. I'm going to click start. Down here in the start, you can see that, we have this JSON the stringified version of the state. And you can see that now we're currently in the taking state, which is what value represents here. And the next interesting thing is it shows you the possible events that the machine can respond to. So right now you see the machine can respond to a tick event, a lap event, or a pause event. This means that if you send any other event that doesn't exist in this array, the machine will not respond because the machine is no longer in that state. So the main premise behind the state machine is every state has associated events. You need to send the associated event before the machine can listen. So the very important part here is if I come back to my UI and I click start again, start has no effect on the machine because it's not part of the next event. So here we see the next event is I can click tick, which is currently what's going on, which is the event and the timer are basically working together. So two real user interactions I can run is lap and pause. So I can either click lap here to sort of log the lap and it keeps running, recording the next lap, or I can click pause, which is pause the timer at this point in time. And as you can see, the current state is now paused, and the next events you can send is reset and start. This is the true power of state machines in the sense that you don't have to write so complicated logic to prevent certain elements from responding to your click events. You basically send them all as events, and the machine, based on the states that it's in, would either accept the event or reject the event and not even respond. And down here in the context, you can see what the current state of the data looks like. And here you see the lab, and this is the formatted version of the lab. And you have the value and the formatted version of the value, which is what is shown here in the UI. This makes it super easy to use the stopwatch in any environment at all. And it's so easy to update these components or update the logic in there. The next thing I want to show you is how this machine, how this machine is so easy to visualize. So we're going to look at visualizing the state machine now. Now, if you have the Xstate extension, Xstate VS Code extension installed, you're going to see this little button above the create machine function. Open Visual Editor to actually edit the logic of this component visually. I'm not going to go into that right now. I'm going to stick to Open Inspector. Open Inspector, when I click on Open Inspector, you can easily see the logic of that component visualized for you, and you can actually interact with that. So within the Xstate visualizer, it reads this entire configuration of my machine, and it shows me that, hey, this is the diagram representing the logic that you've just modeled. And here I can actually interact with it, send the start event to see that, okay, it's now in the ticking state. If I send the pause event, I'm now in the pause state. If I resume or click start again, I'm back to the ticking state. Okay, let me click pause and then let me go reset. I'm back to the idle state. Now, this makes it like super easy to take a screenshot of this, send it to your colleagues to verify that the logic of your component works correctly. And they can come back to you with updates to say, instead of going from idle to pause, can we go to ticking state and like visually help you adjust and correct the model or your thinking of the system without even having to touch the code at all, which is super amazing. All right, so having seen this, let's take a look at how can we easily modify the logic of this component um, um, without making so much changes to the logic, or just having seen that, we're going to take a look at how can we modify the logic of this component easily. So we go back to our slides again. And let's say we get like two different messages from the UX designer on our team and the tech lead or the engineering manager. The engineering manager says, come on, we should be able to reset the stopwatch while it's ticking. That means we should try to provide an event to send to the machine when it's in a ticking state to just like go back to the idle state, or just like clear everything and go back to where it started from. And then the UX designer says, how about if we start the timer after a little delay? I don't want it to start immediately. There's some actions I need to run. I think we should run at that point. So let's just start it at a little delay. If you are not if you are not using state machines, you probably would have to like figure out launching the use interval hook. If you're using React, to sort of like try to modify the logic in there, go to the stopwatch component, tweak some logic in there, add some if conditions, and just get it working, and it's all done. The problem is it gets more complex as requirements changes. But if you're using a state machine, your expression or the way you feel when these logic changes come in should be like, yes, I can do it. I think I can do it. Let's get it done. So let's take a look at how we can get these changes into the state machine itself. So let's start with the tech lead. The tech lead, which is the closest person to us right now, we need to make sure it's happy with us. It says we should be able to reset the stopwatch while it's ticking. So we go back to the machine and we'll take a look at the code itself. In here, in the ticking state, you see that we don't provide an event to reset the stopwatch back to the idle state. But we do provide that event in the pause state in here. So all we need to do is to make sure that we supply this event, this reset event, in the ticking state. And yes, as you can imagine, all that we can do to support that feature is to copy this reset configuration here and just like put that in here in the ticking state, so that now the machine can respond to the reset event. So if I reload the Vite app here again, click start, and down here you can see the next events that the machine can respond to now includes reset. That means when I click this reset button, it's going to respond. So let's do that. There you go. And now we are able to reset while the stopwatch is ticking, which is awesome. Let's try that one more time. We start the machine, now it's in a ticking state, and then we click reset. and it goes back to the idle state, clears the timer, which is awesome. Now that's done. The next thing now again is the UX designer says, can we start a timer after a little delay? And let's see how we can support this feature as well. Now before, initially, we had this start event, which means when you send the start event, we go straight to the taken state. But now the requirement is we want to go to the taken state after a specific time instead of going there immediately. So what we're going to do then is we're going to create a temporary state, and then we automatically go to the taken state, using some auto transitions in X state. So let's define a pre-taken state, which basically means that like the state before it starts to tick. And then we create like an after. In X state, there's a feature called after, which is timer, just creating timer events, which are automatic events based on timers, which if in JavaScript is very similar to using a set timeout. So we say like after 100 milliseconds, then we can come here, copy everything from the start event and paste it here to say after 100 milliseconds, go to the taken state and then record the lap there. So we're going to switch the start transition now, remove the actions here and just say, instead of going to the taken state, go to the pre-taken state. Let's see how that works now. So we refresh the app, we see that we're in the idle state. We can set the start event. When I send the start event, you can see that after a little while, then it actually went to the ticking state and started to count down. Again, I refresh the app so you can see. Then if I scroll up here to also open the inspector so you can visually see what's going on, now the diagram has been modified. You see that when you click the start event, I'll zoom in a little bit. When you click the start event, it goes to this ticking state, and after 100 milliseconds, it goes to the ticking state. So this is super awesome. It means I can easily take a screenshot of this logic, share it with the UX designer, and just show them that this is done. Take a look at this diagram to see what the logic of our app or a component looks like now. These are the really cool parts of X state. Being able to model the logic of a component in a framework agnostic way, use it within a framework, whether with a framework or not, is still awesome. So it means we can run the same piece of logic in React Native and React, or Vue Native and Vue, and as needed in literally pretty much any JavaScript environment. The coolest part is that you can visualize the logic, which is super awesome. You can easily share this with people on your team to confirm if this logic is great or if we need to cater for more use cases within the machine itself. And in the future, Xstate is going to provide a way, and right now it already exists, but it's probably been fine-tuned to visually edit the logic within something that looks like this. So if I show you what that looks like right now, if I open the visual editor, it takes a little while to load, and then you see what the logic looks like. So right here, this is actually a visual editor that actually helps you edit the UI or the logic of your component visually without the need of writing code. You do everything in here, and the code is written for you automatically. Now, these are the benefits of using state machines within your applications. Hope you were able to learn how state machines work, why it's needed, and hopefully you get to use it in your app as well. Thank you so much for having me. I'm really excited for being here again, and I hope you learned a thing or two. Enjoy the rest of the conference.